Okay, today here I'm teaching my masterclass series video number 3, and here are the learning objectives. To be able to understand the concepts of U substitution, integration by parts, trigonometric substitution, partial fractions, and to be able to understand and solve multiple integrals. Okay, then let's start. Here, let's first review the U substitution. Okay. Um, First, let's find U, which is equals to x plus 4. Okay, then du of the derivative of u is just 1 as 1. Okay, then that will be equal to u minus 4 divided by u over du. Okay, now we can I think we can find now our stop. Okay. Okay, now can now find our we can now just simplify this first, so that will be equals to 1 over du minus integral of 4u over du. And now if we solve this, it will be equal to um uh, um wait u, so it goes to u minus 4 ln u. And now we need to substitute back the u here, so it's going to be negative 4 ln x plus 4 um plus x plus 4 plus c. And that's how we solve this using u substitution. So let's clear this and get. And now here's number 2. The u in this is 4x. The du here is just 4 over dx. And then we just what do you call this? Substitute it. So it's going to be 1/4 EU over du, which will be equals to 1/4 EU plus C. Substitute it back. It will be just E4x. E raised to 4x divided by 4 plus C. And that's how our U substitution is commonly done. So we just The purpose of u substitution um, is to substitute um, more complicated numbers with u so that we can easily solve it and understand. Okay, let's clear this and let's move to the next topic. Okay, here we have our technique of integration by parts. And integration by parts, as we have previously encountered, is just is just finding the integration of two factors that that are multiplied together. So, and the formula we will use is this: the integration of u and derivative of v is equals to uv minus integration of v times du. Okay, and let's here we have a example. Okay, okay. So first, let's find u, which is easy to guess as it's x. Du is equals to 1. Dv is equals to cos x, and v is just the integral of cos x, so sine x. Okay. Now, using this, using the formula, we can just write it again. So, uv, so x, oh no, wait, x sine x minus sine x d sine x over dx. Now we can now simplify this as sine x is just equals to negative cos x. So it's equals to x sine x plus cos x plus c, as this is this will be negative cos x, and negative and negative here cancels out, so that's positive. And that's how we solve using the integration by parts using this formula. Let's clear this. Now let's go to the next problem. Okay, here I'm gonna teach you another way in order to solve this problem a using this method. So first we need to write x for ex. Now let's draw a line, and okay, and in this row we need to find the different differentiation of this. So let's first find this out. So x for x raised to 3. Now it's going to be 12x raised to 2. Now 24x, and then it's going to be just 24. Just continue until you get a what do you call this, a whole number and no more variables. And keep in mind, if you're going to use this method, you always differentiate the number, always differentiate what is what you call have a finite differentiation, because if you use this on e raised to x, it's just going to repeat itself. So now now find the integral of this, and the integral of e raised to x is just still e raised to x. So just copy. Now connect this e x. And now, oh, don't forget to mark this as positive, negative, positive, negative, positive. Okay, now you can just write it down now. So it's going to be equals to x raised to 4 e raised to x minus, as there's negative here. So negative 4x raised to 3 e raised to x plus 12x raised to 2 e raised to x minus 24x raised and e raised to x plus 24 e raised to x plus c. Now you can also simplify this as e raised to x times e no no do as 4 x raised to 4 minus 4 x raised to 3 plus 12 x raised to 2 minus 24 x plus 24 plus c. And you can use this method to solve what you think will be a very long integration by parts. So always keep this method in mind. So let's clear this, and now let's move on to the next topic. Okay, here we have trigonometric substitution. In trigonometric substitution, there are three types of ways, and three types of on where you can use the trigonometric substitution. If you have if the integrand contains a raised to 2 plus x raised to 2, and a represents a number while x represents a variable, you can use x is equals to a tan theta. And if it's a raised to 2 minus x raised to 2, you can use x is equals to a sine theta or a cosine theta. And if you can see a x raised to 2 minus a raised to 2, you can use x is equals to a secant theta. Now, you can try to solve this. You can try to solve. Okay. Let's try to solve this. Okay. No. Okay. Wait. Let's move this to this corner so I can. As you can see, we have the formulas here in the corner, and as you can see, x raised to 2 minus 4, that's the same as the type 3 here. So use x is equals to a. So a sec. So a sec. So we'll use here is what do you call it? A squared is equals to 4. So a is equals to just is equals to 2. So 2 sec theta. And then we need to find the derivative of this. So dx is equals to 2 sec 2 sec theta. If I remember correctly, is tan theta, then tan theta over d theta. Okay. Now we can substitute this. So it's just going to be it's equals to 2 sec is it right writing theta tan theta d theta divided by as it's x squared, so it's going to be 2 sec theta squared. And here we can just second squared. No. Oh yeah, I forgot. So second squared is equals to just no. Second 2 second square theta. Oh yeah, it's just going to become 2 tan theta. Now we can just simplify this. This cancels out. The same as the 2 here at the bottom, and then tan theta just cancels out. So all that's left is no. So this was squared, so it's going to be 1/4 cos theta as 1 divided by secant theta is just cos theta over d theta. Now it's equals to 1/4 sine 1/4 sine theta plus c, and this is the answer. And that's how you use a trigonometric substitution, and this time we use the type 3, which is a sec theta. And okay, so let's clear this and move on. Okay, here we have another problem, and as you can see, it's 4 minus x squared. So what you're going to use is type 2. So x is going to be equals to 2 sine theta. Okay, and dx is just going to become 2 cosine theta. Hmm, 2 cosine theta d theta. Okay, now we can just substitute. So that's going to be equals to 2 cos theta divided by um 2 sine 2 sine theta is to 2 and 8 x squared to now first let's make a triangle. If I remember to do how to do this correctly, this is the right angle. Um, this is going to be theta. This is going to be 2 as it's the this is x and this is square root 4 minus x squared. Okay. Now, if I remember correctly, cos theta is equals to this divided by 2. Okay, so it's going to become square root 4 minus x divided by 2 and square root 4 minus x squared. If we transfer it, it's going to be 2 cos theta. 2 cos theta. So the square root 4 minus x squared is equals to 2 cos theta d theta. Okay, now we can cancel out. Now we can first I need to delete this. Okay. Now it's going to be equals to 1/4 as 2 raised to 2 is equals to 4. And just that's going to become sine 1 divided by sine square theta. Now we can also simplify that. It's going to be cosecant squared theta d theta. Now that's equals to 1/4 negative cotangent theta plus c. Okay, but wait. But now the cotangent theta, I need to convert this into an x value. So wait, cotangent theta is equals to wait, cotangent is just remember correct this divided by x. Okay, so it's going to be 4 minus x squared divided by 2. No, not divided by 2, divided by x. So the final answer is going to be 1/4 1/4 square root of 4 minus x x squared divided by x plus c. And now that's the answer. Answer. Okay. Now let's clear this. Clear all of it. So let's move. Okay. We already used type 2 and type 3. Now we're going to use okay. Okay, here we have another topic called partial fractions. Here we have the four different cases, which are distinct functions, repeated linear factors, quadratic factors, and repeated quadratic factors. First of all, you need to first this what do you call this? Distinguish first what are the different what case is it by use by by seeing what kind of factors that is present in the integral. For example, if you have a very long, I mean, if you have a quadratic factor, you use case 3. If you have a repeated linear factor, which is this x minus 1 raised to 3, that's a repeated linear factor, so you use case 2. But if you can distinguish each factor, each variable, and each number, you can use case 1. And if the quadratic factor is repeated to itself, like say here it's squared, but it can also be cubed or raised to 4 or raised to 5, you can use the case 4. Now, let's try to answer some simple questions. Okay, here we have 3x, 3, 3x plus 11 divided by x squared minus x minus 6. If we can see correctly, this is a, you can, you can, if you can see this is, you think this is just a quadratic formula. But if you can see here in distinct function, if you can distinguish the factors, which means you can use case 1 instead of case 3. So let's, okay. X squared minus x minus 6 is just equals to x minus 3 times x plus 2. As you can see, x times x is x squared, x times negative 3 is negative 3x, plus plus 2x is equals to negative x, and negative 3 times 2 is equals to negative 6. So we can rewrite this equals to 3x plus 11 divided by x minus 3 x plus 2. Okay, over the, okay. Now, using the case 1 formula, we can write this as a divided by x minus 3 plus b and x plus 2. Now, we can try to solve A and B using the coefficient method, which is equals to 3x plus 11 is equals to A. As you, in order to even out this formula, you can just multiply this A divided by x minus 3 by x minus 3 times x plus 2. So if you do that, you just cancel out x plus x minus 3 here, as it's going to be in top and the bottom. So all that's left is x plus 2 plus b. As this is x plus 2, all that's left is going to be x minus 3. So plus b times x minus 3. Okay. And as you can see here, for A, okay, now let's solve. For A, x is equals to negative 2. For B, x is equals to into x is equals to 3, as you can see here. Then by by and now we can integrate these values into the initial into here. So 3 times negative 2 is 6 plus 11 is equals to 5. She's going to and if you replace this, 3 times 3 plus 11 is 20. Now we can now solve this by, as you can remember, we using this formula, and we already get this number. So all we need is to get the value of A and B here. So A plus B, if I this is going to be as this is negative 2 is 0, and this is negative 5 for 20 now. 3 3 plus 2 is a 3 plus 2 equals to 5 plus b 0 as 3 minus 3. Now, using this, we can find the value of a and b, which will be b is equals to, as this is negative 5 and this is 5 and this is 0, this needs to be negative 1. And for this, as this is already 0, we need to just find a here. So a is equals to 4. And after doing that, we can just substitute this back. If I forgot, go in the ground dx. So it's going to be 4x minus 3 minus, as this is negative 1, so 1x plus 2 per dx. Now we can solve. It's going to be equals to 4 ln x minus 1, no, x minus 3, not minus 1, minus ln x plus 2 plus c. This is now the answer. Okay, and that's how you solve using partial fractions. And remember, even if this is a quadratic formula, you can just still simplify it so that it will look like a distinct factor, but if you cannot, just use the quadratic formula. Okay, let's clear this and let's move on. Clear. And here's number 2. Here, we can simplify this. In order to solve this, we need to first simplify the integral. So this is going to be x squared plus 4. As this, all of them have x, so x times 3x squared plus 4x, no, x squared plus 4x, oh no, something's wrong, wait, undo, plus x squared, x plus 4x minus 4 over dx. As you can see, this is a quadratic formula, but we can still simplify this. Okay, so it's going to be x squared plus 4 divided by x is 3x squared, so 3x um minus 2 times x plus 2 over dx. And now we can rewrite this using the formulas we just discussed earlier. So it's gonna be a x plus, I don't know, b over 3x minus 2 plus c x, wait, no, we can do this in order. So instead of 3x minus 2, we can do this as x plus 2 to be easier after. So, and then this 3x minus 2. Okay, for dx. Okay. And if you remember correctly, using the coefficient method, we will get x squared plus 4 is equals to a, and times what's the rest? Times what's the rest here? So going to be x plus 2 times 3x minus 2 plus bx times 3x minus 2 plus c times x plus 2. So you just multiply a with the other factors that's not in its denominator. Okay, we can erase this top layer first so that I can solve. Okay. Ah, okay. Now we can solve how we can get what they call this the values of x for a, b, and c. So x1 is equals to, in order to get this, so minus 2 plus 2. Hmm. Wait, using this formula, we can get the values of x. So that's going to be 0, x2. For b is negative 2, as that's the only, I don't know. Wait. Ah, what's wrong with is equals to negative 2, as it's the only thing remaining. And for x3, going to be 2/3. Okay, so as x squared plus 4 is equals to a times x plus 2, 3x. So we can just, as this is all 0, so it's just going to become, I don't know, wait, we can cancel this out. So 0, 0, okay, x squared, cancel out this 2x's, it's going to be just 4 equals to a times 2 times negative 2. Okay. And then for b, x, okay, so going to be, wait, let's see, okay, negative 2 squared is equals, plus 4 is equals to 8, is equals to b, um, negative 2 times 3x plus 2, and that's equals to negative 8. And for c now, um, 2/3, okay, 2/3. It's equals to 2/3 plus 4. 2/3 is okay. So equals to 40/9. Okay. Is equals to um C 2/3 times 8/3 as it's plus 2. Okay. Now we can get the values of A, B, and C. A here is negative is equals to -1. B here is equals to 1/2. Okay, then C here is equals to 40 or 16, and that's equals to 5/2. Okay, now we can substitute it not back. So here's the eraser. Okay, so that's going to be -1, 1/2, and 5/2. Okay, now we can erase this bottom as we don't need it. Okay. Okay. Now we can finish this. So that's going to be negative ln x plus 1/2 ln x plus 2 plus that's going down. So 5, 6. Okay. 5, 6 ln 3x minus 2 plus c. And that's how you solve that the problem for partial fractions. Now let's clear all of this and let's move on to another topic. Okay. Here we have a example of a multiple integral. In this case, this is a triple integral. Wait. Okay. In order to easily understand this, um we can just simplify this all together by using parentheses. This is this is what you first need to solve. Then after that, the answer you get, you need to integrate it again. I don't know. Let's move this at the bottom. And you just need to integrate the answer again to this and again. And keep in mind, the order is from the inside out. And always remember the order of the limits here and what do you call this? Symbols. So first we can solve 108 xy z dz here. And if we integrate that, it's just going to become as it's in the of z, so this is going to z squared divided by 2 And 8 divided by 2 is just 4. It's just going to be 4z squared x y 1 0. Now we can just substitute z here as we as the integral is by dz. So substitute dz is going to be equals to 4x 4xy. Now, after finding this answer, now we can just move on to another integral. So 3 to 4xy over dx. The same will apply. So this is going to be 2x squared y, wait, undo, y, over 3 2. Okay. This is just going to be, wait, so this is going to become 2 3 squared y minus append minus um 2 squared y. This equals to 10. It's going to equals to 10 y. Okay. Now we just need to solve the last one. So it's going to be equals to integral of limits of 2 and 1. Just copy 10y, 10y over dy. Now, if you solve this, it's just going to become 5y squared 2 1. Now 5 squared 2 squared minus 1 squared. So the 4 minus 1 is equals to 3. So times 5, so 15. And that's the answer. That's how you solve multiple integrals. That's a simplification how to solve multiple integrals. Okay, now let's clear this and move on to another example. Okay, here we have another example. Okay, as we remember just now, we need to solve this by from inside out. Okay, so integral of 30 y cos d5 or dx. If you remember, if you see here, there's no x, so just put x. So it's just going to become y cos c5 times x times 3, 0. Now that's going to become 3y cos c 5. That's how simple it is. So let's move on to the another integral. So z squared 0 on 3y cos z 5 over dy. Now here, if you solve for this, it's just going to become um 3 half y squared cosine z5 with c squared 0 on y. So 1 0, this is just going to become 3 halves c raised to 4 cosine c raised to 5 over t z. Now this is going to be equals to hmm wait, sine z5 is going to be sine sine z5 divided by 5. So 3 per 10 sine sine z5, just copy. Okay, now 1 0 equals to 3 per 10 sine, erase this, let's move it to another location. So here, the answer is going to be 3 over 10 sine 1. Okay, and that's how you solve multiple integrals. And you can also do this until fourth integral, fifth integral, and so on. So let's clear this. And thank you for watching.